Good morning, everybody. Welcome to Monday morning before Thanksgiving of Chem 1211 with your host, me, Dr. White. I hope you all had a nice time since we last met. I did. I went to one of the more dangerous places in the world for me, and that's Costco. I try and only go there a couple times a year because I just spend a lot of money there. And I like my top. You've seen them before. I bought a couple more. These are super warm, and they were only $14.95 a piece. So I've got enough for one day of the week. I had a couple I bought last year just to try them out, and I liked them a lot. All right, a lot to talk about, lot to do today, so I better get started. All right, Zoom tells me you should be seeing Chem 1211, Quiz 5, important information. All right, let me remind you tomorrow I will be giving Quiz 5 starting at 11 a.m. Right now, you can go to the assignment area of Blackboard and download that file. It's a password protected file. So tomorrow at 11, or maybe a couple of minutes earlier. Oh, that blueberry tea in the morning is good. But anyways, I will be emailing you the password for Quiz 5. You'll have until Wednesday, 8 p.m. to take Quiz 5 and upload your answers as a single PDF file. I reserve the right to take off 25 points from your Quiz 5 point total for anybody who does not follow instructions, meaning uploading a PDF file, or who does not upload your answers on time. And as I said last week, Quiz 5 has 5 pages, 9 problems, some multiple part, but no multiple choice. It's worth 50, yes, 50 points, and it covers only, there's enough to cover, Chapter 15, Chemical Equilibrium, including the collision theory of reactions, reaction rates, chemical equilibrium, and Le Chatelier's principle. I like my North Side Chicago French accent. Now, you should download the file sometime today, save you time, but you've got enough time. By this Sunday or earlier, 1 p.m., I'll post the your scores of Quiz 5 on Blackboard. At that time, I'll send out an announcement, and hopefully by Sunday, if not earlier, I'll also email you each student your individual points you receive for each problem on Quiz 5. Next, a week from today, Monday, I will go over the Quiz 5 answers, but I will cut them out. Ooh, stereo. Anyways, cut them out from the video, but if you can't make it to my office, my lecture next Monday, I'll be available my office hours. You can't make it to my office hours to see the answers, email me and I'll set up a special Zoom meeting for you. All right. So that's Quiz 5. And today I'll be doing the Quiz 5 review, and I'll be going through the practice problems for chemical equilibrium and Le Chatelier's principle, chapter 15, which is essentially Quiz 5. Now, something I did over the weekend, Sunday, yesterday morning, I decided Thanksgiving Lab Amnesty program. A number of you haven't uploaded your lab reports. And if you didn't, you get 0. However, it's a lab amnesty program because of Thanksgiving this Thursday. And I have reopened all the assignment areas for the posted labs this semester so far. You'll have until 10 p.m. on December 7th to upload your completed labs to Blackboard if you have not already turned in those labs. Again, this is the amnesty program. Labs are worth 10 points apiece. And if you're missing a lot, that's really going to hurt your grade. And if you, when you upload your late lab report, email me so I know to check it and find it. Otherwise, I spend way too much time trying to search who uploaded new labs that were late. All right, I will, because it is late, part of the Amnesty program. Instead of taking off 2 points, I'll take off 1 point for late labs. But if you get a perfect score, you then would get a 9, and 9 is a lot better than 0. Just a reminder, because this Thursday is Thanksgiving. Wow, where did this semester go? Where did this year go? It's Thanksgiving almost. All right, COD, College of DuPage, the actual campus offices for Glen Ellen will be open, but there will be no classes. And therefore, on this Wednesday, I will not have any class lecture, and I won't have my office hour. Don't forget, giving quiz 5 tomorrow, and I'll say it again tomorrow, but I hope you all have a happy Thanksgiving holiday. I think I might have mentioned it, but in our family, the turkey isn't the only thing that gets stuffed. We all do. Oh, boy, what a meal. I can't wait. And one other thing I'd like to remind you that you might want to think about over the Thanksgiving holiday. Don't forget, work on the extra credit project. It's in the assignment area. And I'd highly recommend, one of your colleagues already did, and it helped her, send me via email your project and I'll check it. And if things are wrong, I'll let you know. So this will give you time to fix it so you can get 10, hold on, 10 bonus points. That's like adding 10 points into your quiz or test score, and that will help your grade always. All right. Any questions about all the stuff I've talked about already? Well, in that case, I better get started. Oh, one other quick announcement. I was looking at the schedule and everything. I'll post later in the week, maybe Wednesday or Friday. Next Wednesday, a week from this Wednesday, I'll give quiz 6, and quiz 6 will deal with acids and bases, which I'll finish probably by tomorrow. And I'll post an announcement about that later in the week. All right. Haven't done it this morning. Thumbs up, people. Do you see quiz 5 review on your screen? Thank you, Brianna. All right, let's get to work. All right, for quiz 5, these are things you should know. Hint, first of all, you should know the collision theory. And there are 3 parts that you should know. 1, in order for a reaction to have, molecules must collide. I like those special effects. Reaction. All right. The colliding molecules must have a minimum amount of energy for a chemical reaction to occur. And we call that minimum amount the activation energy. So if they just come together and go ding, nothing's going to happen. But if they come together really forcefully with enough energy, then you have a chemical reaction. And finally, colliding molecules must collide in the proper orientation. And if you put a key upside down into your lock to open a door, it won't work. It's got to have the proper orientation. Hold on, special effects time. my house key I always carry in case I got to go out to get something quick. I need to lock the door. And if I put it in upside down, it won't go in. It's got to go in the lock the right way to open it. Click, it opened it. I like those special effects. And same thing with molecules. When they come together, they have to come together in the proper orientation because this way they don't come together. All right, next, talk about the reaction rate. And that is the rate at which products are made or reactants are consumed. In other words, how fast is a reaction going? And it's measured by concentration of either the product being made or the concentration, the amount of the rate of reactants consumed. Now, important factors that influence the reaction rate. And one of those is the physical nature of the reactants. Are they a gas, liquid, or solid? Then the reactant concentration. How much do you have? And, ooh, this must be important. It's in red. Reaction temperature. Notice I even got stars here and everything. I know stars, but anyways, important. You should know the rule of thumb, and that is the rate of a chemical reaction doubles for every 10 degrees increase in the reaction temperature. I'll say that again in slow motion. You should know this. That's the reaction rate doubles for every 10-degree increase in the reaction temperature. And finally, you should also know, and I really should have this in red also, a catalyst. And what is a catalyst? It's something that makes the reaction go quicker. And you should know, how does a catalyst work? And a catalyst works by lowering the activation energy, and by doing so, it increases the reaction rate. Now, I talked about energy diagrams, exothermic and endothermic reactions. And when we go through the practice problems, I'll show you energy diagrams. You should know how to draw the energy diagram with the activation energy on there. For an exothermic reaction, that's a reaction that gives off heat when it's made. Heat's on the right. And an endothermic reaction, that's a reaction, tea break, that absorbs energy when the reaction goes. Energy is on the left side, or heat on the left side of reaction. Now, I talked about chemical equilibrium, and that's where you have a reversible reaction. A plus B going to make C plus D, and C plus D making A plus B. And we show that by a double-headed arrow. And you should know, for chemical equilibrium, hint that the forward and reverse rate of reactions are the same. Going this way and this way, they're the same rate. Now, important concept is the equilibrium constant, KEQ. K in chemistry, usually one of the ways of showing a constant. And if you have an equilibrium, W moles of A react with X moles of B is in equilibrium with Y moles of C and Z moles of D. The equilibrium constant is the concentration of each product to the power of the coefficient divided by the concentration of the reactant to the power of the reactant, the coefficient. Now, important thing, there are times Common mistake students make. And this is wrong. What they'll do, and I see this all the time, and I'm telling you this, so you don't make this mistake. Students, instead of a multiplication, put a plus sign. That's wrong. Don't do this. It's a multiplication. It's times. Now, when you put a compound in a bracket, that's the chemist's way of showing moles per liter, as I have down here. So one thing, if you look at important information, I don't even know if I got it posted for quiz 5. The only thing I have is a word description of Le Chatelier's principle. This you have to memorize on your own. I've got to do a little this semester. All right. Now, when we have an equilibrium constant, it tells you how complete or to the right a reaction goes. And the larger K equilibrium, the more products. And so if K equilibrium much greater than 1, concentration of products, next time I teach this, I'll put this on here, is greater than the concentration of the reactants. If K equilibrium, the equilibrium constant, is less than 1, the opposite is true. The reactants I can spell, which I can't. Did I tell you I was always the first one down in the spelling bee? And today I probably would be too. And when K equilibrium is less than 1, and this means greater than, this means less than, the reactants are greater than the products concentration. All right, now I'll go through this in a little while in the problem set, but you should know Le Chatelier's principle. And this is the only thing I'll have in important information. An equilibrium shifts to the side to reduce the stress put on the equilibrium. And you should know concentration effects. And I'll go through this in a little while in the chapter 15 problem set, and temperature effects for exothermic reaction and endothermic. Now, I don't have here, but you should know ice, excuse me, when you put a reaction in an ice bath, cool it down, that removes heat. And when you put a reaction in a beaker of boiling water, that adds heat. And this is something you've got to remember. Hint, hint. Again, ice bath removes heat when you put a reaction into it, and boiling water adds heat. And that's the review. All right, I must apologize. About 10 minutes ago, I opened this up and I said, Oh, it was one I missed. And I have some cursive. I'll read it out. Unfortunately, I won't have chance to change this before quiz number 5, but you can go look at your notes, and I just covered it. All right, chapter 5, practice problems. Everybody see that on your screen? Thumbs up, people, or thumbs down. Thank you, Brianna. All right, thank you, Gianna. All right, let's get going. These are important things you should know how to do for test 5. Hint, name one of the key factors in the collision theory of reactions that is needed in order for a chemical reaction to occur. And you only have to name one. Well, the obvious one is reactant molecules must collide. That's why it's called collision theory. And when they collide, collisions must have enough energy to make the reaction occur or to make a reaction. And finally, I have disorientation, and that would have been all right, but they have to have the proper orientation. Next, you should know what is the activation energy. And that's the amount of energy needed to make a reaction occur. That's the force needed in a collision. Now, how do you make a reaction go faster? Well, you learn that adding more reactants will do that. Increasing the reaction temperature will do that. Another one, which I could have written here, and any one of these would be a correct answer. Now, as I mentioned earlier, you should know how to draw the energy diagram for exothermic and endothermic reactions. And here I have a very interesting reaction that changed our world. Actually, it did back about 1910, give or take a year or two. And this is where you take nitrogen, hydrogen, and make ammonia plus heat. It's an equilibrium. Now, when you have this reaction at a certain time, you have a certain amount of energy nitrogen, hydrogen have. And on the y-axis, you have energy. On the x-axis, you have time. So here's where I have it. Now, the conservation of energy states the amount of energy you start with will be the amount of energy you end up with. So the total energy of nitrogen, hydrogen equals the total energy of ammonia plus heat. But the heat is given off. I like those special effects. But anyways, heat's given off, and therefore ammonia, since you're losing some heat, will have less energy than nitrogen and hydrogen. And therefore, that's why we put it lower. And then you have a little hill. You go over the hill and down the hill to grandmother's house. Actually, it's ammonia. And then you should know how to write that where you start to the top of the hill is the activation energy, E act. Now, this is for an exothermic reaction where the heat is on the right. Now, for an endothermic reaction, the heat is on the left. And once again, we say water, ignoring the heat, has a certain amount of energy, so I put it here. Now, again, conservation of energy. You never create or destroy heat in a reaction or energy. Whatever we have on this side will be the same on the right. Well, you have to add heat, so water alone will have less energy than hydrogen and oxygen. Again, the total energy on the left and right are the same, but we've added heat, so the energy of water alone has to be less than hydrogen and oxygen, the products in an endothermic reaction. Therefore, it's going to have more energy, and that's why I have a hydrogen oxygen higher than water. And again, you have the same hill, over the hill and down the hill, the grandmother's, well, anyways, to make the hydrogen. And where you start to the top of the hill is the activation energy. Y-axis is energy, x-axis time. All right, next, how do you write the equilibrium constant, K equilibrium, for the following? And if we look at any one of these, we have the concentration of each product to the coefficient of power of that product, and it's times, not add, divided by the concentration of each reactant on the left to the power of that concentration based on the coefficient. Now, when there's no number in front, like an O2, it's 1, and you don't have to show 1 to the power. And these are all examples you should know how to do. Now, number 7 is predict the relative amount of reactants and products for this equilibrium. Notice the equilibrium constant 2.0 times 10 to the 4th is much greater than 1. Therefore, these 3 dots are math way of saying therefore. Dr. White thinks it's cool to do that, so I did. Am I a cool dude or what? Don't answer that question. All right. The concentration of the products will be greater than the reactants. And if I asked you on this one, predict a relative amount of the concentration of HCl to H2, it would be same thing, products, H2 would be greater than concentration of HCl because of this and this. And if we look at B, here's our equilibrium, and K equilibrium is 3.2 times 10 to the minus 34. When it's minus, it's really, really tiny. I can't even do that. And that tells you the reactants will be greater than the products. And again, 3 dots, therefore, because K equilibrium is much less than 1. Why don't you predict the relative amounts your turn. Why don't you predict the relative amounts of nitrous oxide, NO, and nitrogen gas, N2? Your turn. When you're done, give me a thumbs up. Thank you, Brianna. And don't forget, if you need help, you can always email. Thank you, Anna. You can always email me or come to my office hour tomorrow night. And thank you, Gianna. All right. Now, because K equilibrium is much less than 1, we know this is true. Reactants are much greater, the amount, that's why we put it in bracket. So that tells me the reactant, in this case, this, is much greater than the product, this. That's a better nitrogen. And that's stuff you should know how to do. I have a number of them. Now, let's talk about Le Chatelier's principle. Le Chatelier's principle, like in problem 8, for the following equilibrium, what happens to oxygen and chlorine if you add more water? Remember, at equilibrium, there's a certain amount of each reactant and a certain amount of each product. And if you add or subtract from one another, either reactants or products, you put the system under stress, and then Le Chatelier's principle kicks in because it goes, oh no, I don't have this or I need this, and it'll shift either way to make what's been either disappearing added, or if you have too much, you will go into direction to react that. Remember, when things react, it's consumed and the amount goes down. When you react something or consume, and when you make something, there's going to be more. So if we add more water at equilibrium, there's a certain amount of water. Now there's too much water. How do we get rid of the water? Chlorine reacts with water to shift the equilibrium this way. And if it's going to react with chlorine, it's consumed, therefore the amount will decrease. Since we're going this way, reacting these two, we're going to make more hydrochloric acid, HCl, and more oxygen gas. Now, if we look at C, if I remove some water, oh no, I don't have enough water, the reaction says. So how can I get more water? Again, we're doing C. Well, HCl and oxygen react to make more water, but they also will make more chlorine, Cl2. So what happens to the oxygen? Well, if it's reacting with the HCl to make more water, it's reacting and it's being consumed, and it will be less. It decreases. If it's making more water, you'll also make more chlorine, Cl2, and that increases. All right, let's look at number 10. And here we have C6H6, that's called benzene. And this is called cyclohexane. If you have an equilibrium of benzene C6H6 with hydrogen gas H2, it makes cyclohexane C6H12 plus heat. This is exothermic. And what happens to the concentration of benzene and cyclohexane if you put the reaction in an ice bath? And notice someone was nice enough to write on here, ice bath removes heat, boiling water adds heat. So if we put it in an ice bath at equilibrium, there was a certain amount of heat, we've removed some of it. And it goes, oh no, I don't have any heat. Somebody took some of my heat away. I've got to make more heat. And how does it make more heat? The benzene and the hydrogen react to make more heat. Well, as soon as this is reacting to C6H6, remember when something reacts, consumed, and there's less. And the amount of C6H6 benzene decreases. Now, to make more heat, we're also going to make more cyclohexane, C6H12. And that means it will increase when you make more of something. Now, if we look at B, what happens to the concentration of C6H6 benzene, C6H12 cyclohexane if you put the reaction in a beaker of boiling water? And boiling water adds heat. At equilibrium, there was a certain amount of heat. And now, when you put the reaction in boiling water, oh no, there's too much heat. And it's under stress. Oh no, I have too much heat. I've got to get rid of this excess heat. The only way it can do that is react with cyclohexane to make more benzene and hydrogen gas. And if something reacts, it's consumed. So the cyclohexane C6, and we're doing B, will be consumed, used up. Remember the cookie, if you eat half a cookie, are you going to have how much cookie, more or less? You'll have less in your hand because you ate half of it. And therefore, the C6H12 to react with heat, the amount will decrease, or you can have it narrow down. Now, since this is reacting, it makes more hydrogen and more benzene, C6H6. If you make more something of something, guess what? The amount you have will increase. And I have a couple more similar. Here I have it where the heat, and there should be a plus sign after water. It fell away, it disappeared on me. Oh no, the dreaded plus sign virus hit again. Not really, but anyways. And this is how you do it. Let's go through this one. Now we have an endothermic reaction. How do I know that? Heat is on the left side, the starting materials or the reactants. And the question asks 3 points each, or maybe even 4 points. What happens to the carbon monoxide, CO, and hydrogen, H2, if you put it in an ice bath? Well, ice bath removes heat. Oh, I'm sorry. Yeah, ice bath removes heat. And at equilibrium, there was a certain amount of heat. Now we remove some. And the equilibrium with Le Chatelier's principle said, oh no, I'm under stress. I don't have enough heat. The ice baths took some of it. So I have to make more heat. How can this reaction make more heat? Go that direction where carbon dioxide and hydrogen react to make CO, water, and heat. Well, if something is reacting, it's being consumed. And when something is consumed, you have less. Now, since it's making more heat going that direction, it will make more carbon monoxide and water. When you make more of something, it increases. And what happens if you put it in boiling water? Boiling water adds heat. And now, if we look at this, we put it in boiling water. at equilibrium, there was a certain amount of heat. Boiling water adds heat. And now at equilibrium, and now the reaction says, oh no, I have too much heat. By the way, don't do this too much or you'll lose hair. No, I'm just kidding. But anyways, see what happened to me. But anyway, oh, it's awful humor Monday. Be careful. It might get worse. All right, hopefully not. But anyways, if you put it in boiling water, now you have too much heat. And Le Chatelier's principle states that a reaction will shift the equilibrium in the direction to remove the stress. The stress is, oh no, too much heat. How does it get rid of excess heat? Heat, water, and CO react to form more CO2, carbon dioxide, and hydrogen gas, H2. Well, if you're making more of something, the amount you have here in B, a hydrogen, will increase. If you look now at CO, you're reacting to carbon monoxide, CO, with water and heat to reduce the excess heat. When something reacts, it's consumed, like the cookie, you have less. So that's why the amount of CO, that's why we have in brackets showing the amount, will decrease. Let's do one more because they're fun. Now you know I'm a chemist. What happens if you add more carbon dioxide? And I'll let you try that. I've hidden the answer. And if you add more CO2, what happens to the concentration of CO and H2? And give me a thumbs up when you figure that out. Again, I've added more CO2. Thank you, Brianna. And one thing I should mention, tomorrow, thank you, Anna, after I send out the password to the video for the review, I will put in private or where only I can see it. Thank you, Gianna, until after the end time of quiz 5. That just cuts down on potential cheating. Coming back and look at this. Hopefully nobody is. All right. Now, at equilibrium, there was a certain amount of carbon dioxide, CO2. We've added more. Oh no, there's too much CO2. How do we get rid of the excess CO2? Well, there's only one way. CO2 will react with hydrogen. When it does that, it shifts the equilibrium in this direction to make more heat, water, and CO. Well, if you're reacting the CO2 with hydrogen, it's consumed. The hydrogen is. So the amount will decrease. And if you're lazy on quiz 5, if I put this down here, this type of problem, hint, you can use an arrow or the term decrease or write decrease. Now, it also asks what happens to the amount of CO, carbon monoxide. Well, if we're reacting to CO2 to get rid of the excess, it shifts the equilibrium this way. We make more heat, more water, more CO. And if you make more of something, how much will you have? Will increase. And that's how you do it. And these are all things you should know for quiz 5. Any questions? I'm all ears. Also look down at the chat thing. All right, well, in that case, let me close some things. And remember, the practice problems are in Blackboard, practice problem answers are in Blackboard, and the review is on Blackboard. Oh, I see 2 questions. All right, I better answer the questions before we move on. Let's see, all right, Brianna, first of all, you never, ever, ever in my class or my world have to say sorry for asking a question. All right, for an exothermic reaction, heat is on the right side of these double-headed arrows. For an endothermic, heat is on the left side. All right, does that help, Brianna? Thank you. All right, the other question. And is there any way we can have extra time for the lab that's due tomorrow? Let's see, Gianna, would it help you if I extend it to Saturday morning? Give me a thumbs up, yes, or a thumbs down, no, or send me a chat. All right. Sometime later today, the lab that's due today, I'll extend it to Saturday. Let's make it noon. That way, in case you're busy on Black Friday, I don't go to those anymore. When I was younger, I did stand in line for 2 hours, save a lot of money. It's not worth it to me anymore. Anyways, you can do it online most places. Walmart and other places, you can get their stuff online. In fact, 3 or 4 years ago, instead of going to my local, you're welcome, Gianna, Walmart, I got a real nice deal on a great vacuum cleaner I still have, and it was like half price on Black Friday. So I just, on my keyboard, bought it. They even delivered it free to my front door in a couple of days. What a deal. Gianna, if by tomorrow I don't change that. Take a look. Send me a nasty email and say, you promised. Speaking about promise, let's take a break now. It's a little off, but come back at 9:58, give or take a minute. Let's take a 5-minute break. I'm going to get up and stretch. I'll see you in 5. time to get going. Ooh, minute late. All right, one thing, Gianna, before we get done today, near the end, send me a message by chat. Say, don't forget about changing the lab. That will help me out. All right, thank you, Gianna. All right, let's get back to chapter 14, acids and bases. This will be on quiz 6, not tomorrow's quiz 5. And just a quick review, under the Bronsted-Lowry theories of acids and base, a Bronsted-Lowry acid is a proton donor. I give it up. And under the Bronsted-Lowry theory of acids and bases, a Bronsted-Lowry base is a proton acceptor, H plus being a proton, a base, give it to me, a acid, here, take it. Now, I talked about the strengths of acids and bases, so I'll skip that. Now, switch is totally off for this slide, and there's in the next slide, but I do want to cover it because in other classes you may need to know this. Now, there's something called monoprotic, and that's an acid that transfers or gives up only one proton in its acid-base reaction. Now, in chemistry, the prefix di means two. Di, two. So diprotic, protic being H plus, diprotic acid is an acid that can transfer two protons in an acid-base reaction. An example would be sulfuric acid. And again, switches off. And this shows you these two protons are acidic and can be lost. Now, you can also have tri, and again, switches off. And tri in chemistry means three. And this is one that has three protons it can give up in an acid-base reaction. And polyprotic, poly in chemistry means many. And polyprotic, that's an acid that can transfer two or more, usually more than that, protons in a reaction. Remember, click, switches off. Now, in a molecule, not all hydrogens are acidic. This is acetic acid. And 4% of this, which you learned from the lab, you did for the airbag. Don't forget, if you haven't done it, please get it in tomorrow. You take about 4% acetic acid, I think it's about 4.1, and about 96% water mixed together, you get vinegar. Now, acetic acid is monoprotic because this is the only acidic proton, not the three on the carbon. These are not. And that's just something, again, switches off. I thought I'd teach you. Now, switches on. I better do this. If I had a dial that I could only turn to 10, I've just turned it to 100 because this is so important. What I'm going to talk about next, by the way, click, switches on, dials up to 100. I stole that from the movie. This is Spinal Tap. But anyways, This is probably one of the most important concepts in chemistry. The next couple of things I can teach you, and deals with acids and bases. Now, first of all, let's just talk about, I'm off by a slide, but let's talk about acid dissociation constant called Ka. This I'm going to click switch off. I got ahead of myself. Bad Dr. White. But anyways, normally you have the concentrations of the products, K equilibrium, equal concentration of products, and notice I'll have a coefficient of 1 times divided by the concentration of the reactants. Now there's a problem here, and that's with the amount of water, the concentration. Compared to the other three values, H3O plus, that plus should be inside, not outside. A minus and HA, the acid, they're going to be tiny. That concentration of water is going to be huge. So that means that number K equilibrium is useless. To make something important, chemists decided to drop that for the equilibrium constant of an acid, which is this. And when Ka is large, that's a strong acid. When Ka is small, it's a weak acid. Same thing with base. The equilibrium constant for a base, called the base ionization constant, K sub B, you again eliminate the water. And when Kb is large, strong acid, Kb small, weak acid. And the switch should have been off for these two slides. Now I can do it correctly. I got ahead of myself. All right, this is probably one of the most important areas, next couple of slides, and I mean it now. Zoop, turned it up even more. It's important. I'll make it really important. All right. Now, it turns out water is the most amazing chemical, keeps us alive, and water can react with itself. Everybody see the dissociation of water on your screen. Thank you. I'm going to have some before I. And the water in this bottle, anywhere you see water, this equilibrium occurs. Now, if you notice, I have a tiny little arrow going to the right, because most of the time, this is the major product. Now, if I were to say, what's the equilibrium constant for this reaction? It would be this. Divided by this. Once again, we have the problem. These will be small numbers. This will always be a huge number, essentially the concentration of water squared. That means K equilibrium for this reaction will be meaningless. So what did the chemists decide to do for this reaction? Let's do that and come up with a new constant. And that new constant is Kw, named after me. Not really, but it makes me feel good to think so. Those are my initials, Kw. And this is the ionization constant for water. And what this is the hydronium ion concentration times the hydroxide. I really should have 1.0, is 1.0 times 10 to the minus 14. Now, this is temperature dependent. So Kw, I always smile when I say that, my initials, is for water at temperature 25 degrees. And if you go to colder or hotter, it will change somewhat. But for the most part, the ionization constant, Kw, no, is the hydronium ion concentration times the hydroxide equals 1.0 times 10 to the minus 14th. Oh, know this. Yes, know this equation and the value it's equal to. Now, this is a little outdated, important information, which I've got to write up for quiz 6. I will give you this, but you got to know how to use it. And notice I have a question. If the hydronium ion concentration is 1.0 times 10 to the minus 4th, then what is the hydroxide ion concentration? Well, how do you do this? Well, what are we being asked to find? The hydroxide concentration. What are we given? The hydronium ion concentration, 1.0 times 10 to the minus 4. And by the way, those are moles per liter, but I usually don't put units down. Now, we are also given Kw, hydronium ion concentration, times hydroxide equals 1.0 times 10 to the minus 14. We want to solve for hydroxide OH minus. So if I look at this, I forgot to put a little times there. If I want to get hydroxide, I need to get rid of this. Remember, anything divided by itself equals the number 1. And therefore, I'll divide this side by hydronium ion, H3O plus concentration. Again, because of this will cancel out, and I'm left with the hydroxide. But whatever I do to one side, I have to do to the other. And now I'll rewrite this because you know Dr. White likes to do that. And then I'll put the number in for this, which we found we're given. Now, I don't have to use a calculator for this, because I know how to do this in my head from knowing slide rules, and that would be our answer. So it's important to know when to use the water ionization constant, Kw, not named after me, but I wish it was. Well, it sort of is, and that's important. And I could also have a problem solve for H3O plus given hydroxide. And you'll see that in the practice problems, which we'll do next week. All right, now there's a term that's very important, or terms called acidic, basic, or neutral solutions. And here you should know this. Oh, I haven't been subtle today. Subtle. You should know what is an acidic solution. That's the solution where the hydronium ion concentration is higher or greater than the hydroxide. And you can think of it this way. Now, in your stomach, you have liquids plus the food you ate. And the stomach fluids, your stomach fluids and mine, are acidic because you have cells that make HCl. They react with the water to make a lot of H3O plus. So we know in your stomach, the hydronium ion concentration is greater than the hydroxide. And that's called an acidic solution. Now, a basic solution is the opposite. That's where the hydroxide is greater than the hydronium ion concentration. You should know this. And again, basic solution, hydroxide concentration is greater than hydronium. I won't ask it on a test, but this is called an alkaline solution. Ooh, that reminds me of something. How many of you ever heard of alkaline batteries? I see one person. And that's because in the batteries, do I have one handy? Oh, I do. This is from, I bought it a long time ago from IKEA, and says alkaline, and I guess that's Swedish. But anyways, inside of here, the hydroxide concentration is greater than the hydronium. Yes, there's liquid in here or gel, and that's true. Now, lately, with all my flashlights, I'm not sure if this is a basic in here too, or acidic or what, but my rechargeable lithium batteries are, I'll have to look it up. Are they acid or basic? But they're fun for all my flashlights. You see it? This is a blue thrower. I have to get that in. Supposed to get 2 more today in the mail. Oh, am I excited. Yes, I'm a flashaholic. I like flashlights. All right, let's get back to acids and bases. All right, so basic solution, hydroxide concentration is greater than hydronium. And finally, a neutral solution, the hydronium ion concentration is equal to the hydroxide concentration. So we have 3 different types of solutions. Acidic, and remember, hint, you should know this. Acidic hydronium ion concentration is greater than the hydroxide. Basic solution, hydroxide is greater than hydronium. And neutral solution, the hydronium is equal to the hydroxide. Now, if you think about it, if I say the hydronium ion concentration is 1.0 times 10 to the minus 5th, and the hydroxide is 1.0 times 10 to the minus 9, well, is it acid, basic, or acidic? Oh, I've got to think about 10 to the minus 5th, 10 to the minus 9th, which is smaller, which is larger. Oh, I've got a headache. Well, it turns out chemists came up with a better idea to quickly know if your solution is acidic, basic, or neutral. And of all the things I'm going to teach you this semester, for you personally, this is probably the most important. Yes, it is. And what is this most important thing? And that's called the pH concept. And the pH concept is a scale of small numbers used to specify the hydronium ion concentration, and this is important, in aqueous solutions. And this is probably one of the more important things, if not the most important concept I will teach you this semester. So pH concept tells us what the concentration, gives you an idea, the concentration of the molar hydronium concentration in aqueous solutions. By definition, pH minus the log of the hydronium ion concentration. Hint, know this. Now on quiz 3, I will give you this, but you have to know how to use it. And pH is minus the log, and logarithm is what number to the power 10 will give the number inside the bracket. And the log of 10 to the 5th would be 5. Now, the log of 10 to the minus 6, well, what number to what power 10 would give 10 to the minus 6? And that's minus 6. Now, if you do a minus of a minus, then this becomes a positive number. Now, I'm going to give you a very special Thanksgiving gift. And my special gift is on my quiz and test, H3O plus will always be 1.0 times 10 to the minus x. And therefore, if this is the number of the hydronium ion concentration, the pH will always be x. Again, if this is the hydronium ion concentration, where the first number is 1.0 or 1, then the pH will always be x, the number 10 to the minus whatever. Now, again, important, know this, pH range is from 0 to 14. The lower the pH, the more acidic a solution is. The higher the pH, the more basic. Now, this is a logarithmic scale. Each number changed from 0 to 14, like from 2 to 3, is a power of 10 change, not just 1, 2, but power of 10. So going from 2 to 4 is 100 times different. So it's an interesting scale. Can I write this any larger? This is something you should know. At pH 7, your solution is neutral. pH 7 is neutral. Below pH 7, it's acidic. Below pH 7, it's acidic. Above pH 7, it's basic. The more higher, the more basic. The closer to 0, the more acidic. This you should know. I will not put this on important information quiz 6. This is something so important in your daily life for the rest of your life. You should know this. pH scale goes from 0 to 14. And the lower it is, the below 7, the more acidic. The higher it is above 7 toward 14, the more basic. When you're at pH 7, that's neutral. Now, pH and its equilibrium plays an important part in our daily life. How so? Everybody see my blood? Oh, they're invisible today. I hear some. See my blood veins there? Well, blood is a water, actually a colloidal dispersion, but it's like a solution. You can measure pH of it. And your blood pH should be very near neutral. If you get too low, it's called acidosis. I don't know what they call it when it's too high. And either one will kill you. I don't know if you've ever seen the movie, the original and the remake stunk, called Andromeda Strain. And that was a movie that dealt with the pH of blood. Everybody see on the right where it says pH scale, it has stomach acid, vinegar. Thank you, Gianna. Now, water, quote unquote, should have a pH of 7. It doesn't. I'll tell you a story in a little while. Now, ammonia is a base. And guess what? It's pH 11. And notice it's alkaline or basic. And drain cleaner, depending on which one, some can be acidic or basic, can be as high as 14. Baking powder or baking soda is slightly basic. Your blood they have here is 8. It's really awful little. Vinegar, which is acidic, has a pH of 3. Lemons and limes, which contain acid, not HCl or sulfuric, but citric acid, which is an acid, gives off a proton, has a pH of 2. Your stomach acid is very acidic. Why? Because there's an acid present, HCl. And batteries, like your car battery, which are not alkaline batteries, those are acidic batteries. Why do I say acidic? Because the pH is close to 0. That's really strong. If you notice, they have different charts here, which are all interesting. Let's look at this one. No, doesn't show anything. And I guess it's slightly basic. The pH of your blood ranges from 7.35 to 7.45. If it's outside that narrow range, you're dead. Well, here, if it's too high, that's not good. And if it's too low, death and coma. That's not good either. So the pH of your blood is very important. It's an equilibrium. And your body uses, guess what? The Chandler's principle to keep it in a very narrow range. But you know you are using the Chandler's principle in your body, in your blood. You are. All right, so once again, you should know pH goes from 0 to 14. Below at 7, it's neutral solution. Below 7, it's acidic. And above 7, it's basic. The closer to 0, the more acidic. The closer to 14, the more basic. Not a happy story, but a true story. When I was at one company where I had a research group, and this master degree chemist, someone who had a master degree in chemistry, gave me a report that I would read and proof before it got sent out to the company. And that was part of my job to make sure garbage didn't get set up. And I looked at that report and read it, and I called him into my office. And I said, "Do you like working here?" And he said, "Yeah, why?" I said, "If you ever give me a report like this, I'm going to fire you within 24 hours. Got his attention. What got me so mad? He had pHs in his report of 16 and 17. You can't. pH cannot be ever higher than 14, can never be lower than 0. It can't. He didn't calibrate the instrument properly. He should have known that. And I let him know I was really upset. He got the message. No, luckily I didn't have to fire him, but he saw certain things will get me upset, and you don't want Dr. White ever upset. I don't want to be upset. All right, let's remember pH is minus the log of the hydronium ion concentration. And when the hydronium ion concentration, H3O plus, is 1.0 times 10 to the minus X, the pH is X. This is my gift to you for Thanksgiving and the end of the semester coming up shortly. All right, let's do some problems. Remember, what I'm going through is for quiz 6, coming up a week from this Wednesday. All right, everybody see on their screen, 6 points. Thank you, Brianna. All right, let's go through this. If the hydronium ion concentration, that's what this is equal to 1.0 times 10 to the minus 2, what is the pH of the solution? And is it acidic, basic, or neutral? So what are we trying to find initially? pH. What are we given? This. And what do we also know? pH equals minus the log of the hydronium ion concentration. Well, if I'm trying to get pH and I have this, I now know the pH is minus the log 1.0 times 10 to the minus 2. And if the hydronium ion concentration is the minus log of 1.0 times 10 to the x, then pH is x. Well, what's x in this case? 2, not minus 2. Remember, this is 10 to the minus x. Therefore, pH is x. And now I can say the pH is 2. That's my gift to you. That way, even though I know how to do it, I'm not going to expect you, because you're not going to be chem majors, to know how to use your calculator, which is on there, to do logarithms and then multiply times minus 1. Next, we have to figure out, is it acidic, basic, or neutral? And you need to remember pH scale, 7 is neutral, below 7 is acidic, and above 7 is basic. So, is this acidic, basic, or neutral? Well, 2 is below 7, so this is an acidic solution. All right, let's do another one. All right, why don't you first figure out what's the key thing you're being asked and what are you given? And give me a thumbs up when you figured that out. We'll do this stepwise together. Again, all I'm asking you to do now is, what key number are you being asked to calculate and what are you given? Thank you, Anna. And we'll wait for everybody else to finish. Thank you, Gianna. Thank you, Brianna. Thank you, everybody. Oh, it's a thank you month. No, I gotta wait till Thursday because it's Thanksgiving then. Oh, I told you humor would get bad today. That was awful. All right, we're trying to find the pH as small p, capital H, and we're given the hydronium ion concentration. Now, pH equal minus the log of the hydronium ion concentration. And for my class, that will be given to you. Your turn to calculate the pH. And while you're doing that, I should say Measuring the pH of things is very important in many of the things you buy in your daily life. One of the more important areas is any of your personal care items, like skin creams, cosmetics. Those are all very closely kept in a certain pH. It's called the specification. Because if the pH is too low or too high, it'll irritate your skin or whatever you put it on your body. You don't want that to happen. All right, when you're done, all we're doing now is the pH. Give me a thumbs up. Thank you, Brianna. And thank you, Anna, and Gianna. All right, what are we trying to find? pH. pH equals minus the log of the hydronium ion concentration. And if we put in this number, and notice I give you this when this is 1.0 times 10 to the minus x, the pH is x. So in this case, what's minus x? Minus 9. Therefore, the pH is x, or in this case, 9. Now, is this acidic, basic, or neutral? You should know, hint, the following. pH 7 is neutral. Below 7 is acidic. And above 7 is basic. Since 9, I hope you all know, is above 7, this solution is basic. And the higher that number, the more basic it is. If I look at the clock, we're just about done. So I better tell you a couple important things to remind you. One, first of all, tomorrow, Tuesday, the 22nd, at about 11 a.m., I will send out the password for quiz 5. You'll have until Wednesday, late in the day, like 8 p.m. or whatever. I may even change that to 10 p.m. But anyways, you'll have until late Wednesday to upload quiz 5 as a single PDF file. If you do not have a printer, just on a piece of paper, write down the problem number. Don't forget to put your name on there, the problem number, and show your work always if you have to, and the answer. And don't forget to upload it on time by Wednesday, whenever, 8 p.m. or whatever. Don't forget the lab, the airbag lab, if you haven't handed it in, is due tomorrow. But the other lab we did, which was the equilibrium, if you haven't had it done, due to one of your classmates, I'll give you until Saturday to hand that in without any late points taken off. Don't forget about my Amnesty program, and don't forget about the extra credit project, and don't forget, we'll have lecture and lab tomorrow. With that, I'm out of time. Have a nice rest of the day. Gang gesund. Remember, that's Yiddish for going hell. The pandemic is still out there. I don't know if I told you this. Last Friday, I got my 3rd booster, the newer booster. So I'm all set, even though I still wear a mask when a few people do, but I want to stay safe. With that, I'll say gang gesund. Goodbye. Stole that from Granny to Beverly Hillbillies.